We're waiting for one more microphone, and then we'll get going. In the meantime, think about the questions you want to ask them. You just sat through a full day of bombardment about service mesh and all the exciting things that are happening in this ecosystem. I'm sure it jarred some questions, so let's get them going. All right, to kick off, we're going to have the panelists here introduce themselves and explain what they are excited about in service mesh land.
So I'm Idit, I'm the boss apparently. So I'm from Solo, I'm the founder and the CEO of Solo and Christian Boas, and yeah, and what else? So yeah, so we're building a lot of stuff like you heard I think before, so we all in service mesh. Kind of like, we don't have a service mesh, we are not owning a service mesh. I know it's strange in this ecosystem. We actually just orchestrating those service mesh to your choice. We are the one who founded the SMI as well, together with Morgan and the others. And yeah, that's all.
Hi, I'm William Morgan, one of the creators of Linkerd, and the question was one thing that we're excited about
is, yeah.
I'm excited about what the service mesh enables.
Yes.
Dive.co.
Hey, I'm Zack. I'm a founding engineer at Tetrate and one of the early engineers on Istio. And what excites me is the same as William, right? I think both of us have been working in the service mesh space for a little while now, and it's really exciting to see what people can go and do once they actually adopt it, right? That's kind of when the journey starts.
Hi, I'm Louis Ryan. I work on Istio for Google. Like Zack, I've been on the project since the dawn of time. I think what's exciting to see, particularly today, and maybe a bit of a shift from previous KubeCons, is the number of things being built on top of service meshes, right? I think service mesh is infrastructure. Infrastructure is supposed to be boring. We're working very hard to make it boring, and all the exciting stuff should happen on top. So more exciting stuff, WebAssembly, the Solo thing they showed earlier. There's lots of examples of this now, and I think that's really cool to see.
Yeah, hi, my name is Linsa. I should wear my Istio shirt, but I was trying to be vendor neutral for this morning, so apologies for that. I work for IBM. What excites me about Istio is I remember about service mesh in general is I remember 2 years ago when I started working on service mesh, oh my gosh, it's so hard to use. I remember I was trying to move one single application onto service mesh. It took me a week. But recently, when I tried some of the service mesh project, not just Istio, I actually tried some of the other projects. It's just amazing how easy it is to use them, how easy it is to onboarding your applications onto service mesh. So I think the community has done tremendous work to make service mesh more consumable, more adaptable to you guys. So that's what I'm really excited about.
Hey, my name is Luke. I'm an engineer on the console team. And what I'm excited about is, I mean, it was kind of funny when Michelle asked like how many people are running service mesh in production, and still it was like not that many people. So I think there's a lot more lessons and things to learn from real practitioners once that actually starts to grow. And I'm also really excited about the ecosystem. I think you just mentioned that. Like I think there's a lot of really cool things we can build on top of the service mesh, and kind of just like wait, Kubernetes, that ecosystem is just going crazy. I think there is some potential there for a service mesh as well.
Very good. Thank you for the introductions. Let's open it up to questions. We have about 25 minutes worth of questions.
Well, actually, I have one question with two parts. One is that we have seen in case of container orchestration platforms, we saw there was a alphabet soup of platforms, Kubernetes and Swarm and Mesos and all this thing, and eventually one won out. I heard MSI, and MSI's purpose is to make a neutral layer so that multiple service meshes can coexist. So why is an emphasis on that? What makes you guys think that one service mesh will not win out? The second part of the same question is that service mesh is very hard. Not to you because you live and breathe it, but to an ordinary developer, Kubernetes and service mesh is very, very hard to learn and master. Do you really think an enterprise would be running like 3 different types of meshes and it would need a layer on top of it to talk to each other. I don't see it happening. If you could, please.
Good.
I would be remiss not to mention that HashiCorp has Nomad as well that runs containers. I'll give my quick answer and I'll pass it over to the folks over here. I think there probably will be some service meshes that win out. I think that makes sense. There's going to be consolidation. But I think it might be a little bit different than Kubernetes in that networks might have a little bit way more kind of different use cases. And so I think there is some more complexity there, but that's my short answer. Who wants it?
I'll quickly answer too before I pass it over to you. So the way I look at SMI is interesting demo from Michelle today, but I'm looking at SMI as stuff we accomplished like 2 years ago. That's when I go to KubeCon 2017 North America, I would demo Canary deployment with Istio. So I think SMI is a nice concept, but it's really hard to bring all the vendors together. And at the end of the day, it's going to demonstrate capabilities from vendors that's commonly implemented across different vendors, which is where SMI today, like Canary deployment, but a lot of projects like Istio are way ahead of just Canary deployments.
I would like to take it. So here's the thing. Why Kubernetes won? It didn't win because it was the best. It's pretty good, but when it started, it wasn't that good. The reason it's actually won is because the big cloud and the big provider chose it. Now, all those people create this community and make it better. That's not the case with Service Mesh. The Service Mesh has the big 3 cloud, each of them has their own Service Mesh. Not talking about the fact that this guy started the Service Mesh ecosystem, right? So, yeah, just giving the credit, right? So, I mean, and he's doing really well, right? So the point is that the reason they're going to be more is because I don't see that there is a huge kind of like, it's again, as someone who's looking at this, by the way, I don't have a service mesh, I don't care what was one, is that it doesn't look that the big guys actually agree. And if they're not agree, they will compete. And if they'll compete, they're going to be more than one. That's number one. And number two that I will tell about service mesh is that a service mesh interface, and again, this is not technically, doesn't matter who is the best one, we know this, right? Not always the best technology wins. So it's not about if it's good or not, right? So that's that. Now, I can tell you that I have customers, and they came to us in the beginning and they said, we are all in SEO. And they changed their mind. Why? Because they understand that in a big organization like this specific bank that I'm talking about, there is more than one group. And if you will go to Google, you should use Istio. You should. It's probably building, to the gits and the guts. If you're going to AWS, same thing, right? They will give it to you for free. I mean, it doesn't make sense. It will connect you your EC2. You have to use this, right? And then if you're going on-prem, maybe you want to use Linkerd. So the thing is that big organization has different groups. They have different needs. Maybe they want VM. Maybe it's a greenfield. They're going to be more than one. And I don't see the collapse happening. Actually, what I see, every day a new service mesh is announced. And more to come, by the way. So
I'll leave SMI aside. I think people have talked about it enough about it. I've tweeted about it enough too. With respect to the question around multiple service meshes, I think this is kind of interesting because it's part of the justification for SMI. It's not the total. There's many reasons for SMI, but it's a nice part of it, right? I don't think that that's actually particularly likely in most organizations, and the reason for that is because the single benefit of a service mesh is consistency. Right? Consistent policy, consistent telemetry, consistent traffic control. And so by adopting a variety of mesh implementations, you largely give up that consistency. And so I just don't see, I have not witnessed organizations making that decision, right? I have certainly witnessed organizations investing in investigating multiple meshes. But my experience has been that once they make the technical determination around which one fits their case, they've gone all in on that and it's served them better, right? And again, the watchword for a mesh is consistency, right? And so SMI tries to provide consistency via the API, but to Lynn's earlier point, the problem with that is that today it's a lowest common denominator, right? And in my opinion, I don't believe that we have explored the space enough with respect to how we present the system and how we model it to really be able to judge what is or is not the right abstraction across these heterogeneous implementations.
So I think Idit and other folks have covered pretty well the various backgrounds about what mesh implementations there are, which ones are going to be competing for what mindshare and user space. More generally, just thinking about what people want out of the mesh, the one pattern that I've seen when I go and talk to people who are doing largish deployments, and largish deployments take a long time, they have a lot of internal operational best practice that they're trying to represent in some complex set of systems like Kubernetes and a service mesh. And they're trying to meld that with their internal business process. And so what you see them doing is creating abstractions, their own APIs for their own business process, and then writing their own tooling to convert that into the underlying infrastructure. Right? So when I say Istio is infrastructure, right, it's a target for a derivative of a higher level process that you want to represent. Right? One of the things I was excited seeing the demo today from Solo on Autopilot was tooling to help people build that kind of process easily. But there's just lots and lots of examples out there of when a business wants to represent their business process, right? There's a lot of information that's proprietary to them, to how they review things, how they deploy, how they name, how they structure, how they approve, the services and workloads and everything else they're rolling out in their environment. And the nice thing about Kubernetes and the thing everybody's done in service mesh land and in this world is they've built good APIs. So it's fairly easy for an internal IT shop to take their representation, their approval flow, the information they care about, and convert it down into that system. Right? And that's actually not that hard to do. And so we've seen a lot of people doing that. And that's really valuable, right? Because they get to think in their own business terms, and there's only a small amount of code that's converting down into an internal infrastructural representation. Right? And we saw that with cloud in general for years. Right? This isn't unique to service mesh or Kubernetes. Right? This has been a pattern in internal IT for well over a decade.
Another question? We're starting to get going here. Don't you feel it?
So the question is, Linkerd V1 was initially focused on using node agents and then switched to sidecars afterwards with V2, and Istio just made a decision on using sidecars right away. So the first question is, what made you make the decision around doing the switch? The second one is, do you ever foresee that later on we're going to just go back to node agents?
Wow, that's a Linkerd question. All right. Yeah, I can tell you why we made the switch. And, like any engineering choice, there are trade-offs, and not everything is, 100% in either direction. But yeah, in 1.x so actually in 1.x you could deploy it either way, right? You could deploy it as a sidecar, you could deploy it as a daemon set, and we mostly pushed the daemon set pattern because, on the JVM it was kind of, by virtue of being on the JVM, it's kind of a heavyweight process, and so you got better resource usage amortization if you're doing it per host. But there were certainly organizations that were deploying 1.x JVM Linkerd as a sidecar, and were kind of okay with it, given the benefits they were getting out of it. But for 2.x, we went down the sidecar path, mostly because it makes a couple things easier. One is, I think it all comes down to you have better kind of compartmentalization of what the sidecar, what the proxy is actually going to do, right? By attaching it to an individual application instance, then the security boundary is really clear. A lot of the operational aspects of it get very clear too. Like if it's in a weird state, you kill it and restart it, and we have all sorts of semantics and mechanisms for doing that in Kubernetes. If it's in per pod and you have this multi-tenant thing, then it's harder to do that, and then upgrading things is harder. You just have a decoupling, in a bad way between the services and the kind of the proxy that's sending traffic to and from them. So overall, the other big thing for us was we really wanted to have mutual TLS, and that's not really effective in a daemon set world, because you're sharing those certs across everyone in the system, which kind of defeats the purpose. So those were all the factors that led us to wanting to do it in a sidecar model. We had to rebuild Linkerd from the ground up and get off of the JVM and do a bunch of other work to get it down to the point where it was small enough and fast enough that it made sense to deploy it as a sidecar, where you would end up with thousands or tens of thousands of these things. But those were the main benefits for doing that, and it's worked out pretty well. Does that answer your question?
Next question? Oh,
Is there sidecar commentary?
So we had a really quick talk, extremely quick talk on network service mesh. And, it's interesting because a lot of the things he talked about, like federating different service meshes and things like that, technically we can do it at layer 7. Maybe not as efficiently, but we can. So I guess the question I have is, do you really see benefit in having a network service mesh and an application service mesh, or does it just clutter the conversation and make things harder to configure?
Yeah, so I think it's a really interesting question. I think part of this gets to what service mesh will evolve into, right? So one way to look at the network is that it is another accelerator, right? So your GPU is an accelerator that I can offload embarrassingly parallel computation. It turns out that you can do like HTTP header parsing in a switch or in an NFV, right? You can push this into pipelines, into P4, right? And so I think that what the end game for this space is that users will declare intent, hopefully in terms of some kind of quality of service for different classes of traffic. And operators will realize that quality of service using a variety of technology up and down the stack, right? And that can include network virtualization, that can include pushing it into switches, that can include doing it in a user space proxy, right? And so a nice world that we could end up in is like a Dutch auction for quality of service, right? And using that, we decide where we schedule, right? Obviously that's gonna be a long way away, right? So in the interim, I have a particular hat in this race. So in the interim, I don't see the layer 3, the lower layer stuff being as compelling because we can do it with an overlay. So for cases or not necessarily an overlay, but we can do it at L7, right? So for cases where the performance isn't so essential, I think it's a lot easier to operate. It gives you nouns that are closer to what developers want to deal with.
all right. We got another question here, and I promise I'll make it to the other side of the room.
Could you share your thoughts on how you think service mesh will integrate with the Internet of Things?
Does anybody else want to take that one first, or I can?
You've probably done more than that.
Yeah, so that's another particular area of interest of mine. So we do, that's the advanced networking stuff is pretty interesting, right? So yeah, there's a whole lot of really interesting capabilities that a mesh provides that are very interesting for an IoT. I would argue, I think I've said before that the single most important feature that a mesh provides is identity. Identity is maybe one of the most essential building blocks of anything on IoT, right? If you don't know what that device is, if you can't positively authenticate it, then it's not really very valuable to do anything else. And so in particular, so obviously the whole range of network resiliency features are pretty compelling in this IoT use case where we have worse networks and things like that. But I really think a lot of the killer use cases are going to be around identity. I think we can look at Android and how the Google, the GMS, the Google Market Services handles identity between apps going into Google APIs is a really interesting case point for how you start to do device identity, and I think we'll start to push that further. So I think that there's a really promising area there, but I think it's still very nascent. And things like trust are still very, very challenging to set up correctly in that system.
There's also the boring plumbing part, right? I mean, most of the IoT devices out there want to speak some, low footprint protocol, CoAP, MQTT. I run out of the names of acronyms pretty fast. And there's a large number of those running out on either internally on your network or at the edge or beyond the edge of your network, and you're going to want to be able to bridge those in and have them talk to services and do all the regular service mesh rowdy things, right, and the policy things and the identity enforcement things. So one of the reasons why we were super interested in WebAssembly is because we think it gives us the ability to add dynamic protocol support to the network, right? So you could start to treat CoAP and route CoAP like you routed HTTP, for example, or do the same thing with MQTT, right? And hopefully we'll start to see those types of things happen, where people can add extensions at the edge to, or even in sidecars to route these kinds of protocols, because you're going to need the plumbing as well.
Yeah, I was just going to add, I remember Matt Klein, I think maybe 6 months ago, he tweeted about he was super excited to add mobile support to Envoy. So that really helps us to enable implementation of these scenarios of service mesh with IoT.
All right, more questions? Back here, this side? Nobody?
Hello? Yeah. So I think just to add to the current topic on IoT and also possibly network service mesh, I mean, how do you guys envision all this? I mean, I know there's a lot of standards related that are not necessarily fall in place, but how do you say this, in terms of roadmap for any of the service mesh that we are seeing now? Maybe I would want to say like next 5 years or 2 years. Yeah.
For things like some of those IoT use cases and stuff like that, yeah, I would be very happy if in 5 years we have people doing like production use cases with that, right? I mean, it's very hard to guess to some degree, right? It's really going to boil down to are people going to pay money? Do people that are paying money have that use case in the next 5 years? Is really going to be the differentiator for that, and that's really going to boil down to, do you need really extreme performance while still keeping a lot of this consistency, right? At least for the network service mesh side of it, in my mind, right? The device identity side of IoT, I think, is actually a much more pressing reason for that to start to happen sooner. But I think that it's more likely that identity there manifests in different ways first, and that a service mesh will use those rather than the service mesh being the answer for identity in IoT devices out of the box.
Question?
So, how many sidecars is too many sidecars? I know it's not specifically a server mesh question, but I've had like 5 sidecars before, and that's a lot of sidecars, but I also haven't seen a problem with it. Like, I haven't necessarily seen huge hits in performance, so is it a problem, or does it just kind of look silly?
This is in one container or across your entire?
I'm talking about like, yeah, maybe like, yeah, in a single pod.
7.
Especially when you're like retrofitting things for like Prometheus exporters and stuff like that.
Yeah, no, it's 7. 7's the max.
At Google, we actually go up to 11.
Yeah. You have to have Borg to do that, though. It doesn't do it on Kubernetes. No, I mean, like, so this is part of the problem with like how you cost a service mesh too, right? So those sidecars are pulling out functionality. So like the worry with the sidecars is it's less efficient than doing it in binary. In some sense, right? And so but the other side of that is you're also not doing it in your binary. So the cost accounting is kind of hard there, right? So as long as you're comfortable with the cost of your sidecars and the value that you're getting out of that relative to, I mean, that's not a very hard answer, but as long as you're happy with the value for the money that you're spending, then you just keep slapping those sidecars in there.
My money's on 7 for sure.
Yeah, I mean, some of the sidecars are, not playing a strong role in security, probably, and so should really be shared resources, but haven't been implemented that way, and so it's a convenience, not a necessity, right? If they're playing a strong security role, right? So the 5 sidecars that are not doing strong security things, right, and should be running as shared infrastructure, go nag those people, so you can get back down to 6 or 4 or however many. Below what the 7 is, or whatever we agreed the limit. Yeah, that's right. Some of it's just about evolution and maturity of products, I think.
How do I use the service mesh in a message-driven microservices environment, which is not HTTP?
If you read William's blog post he posted 2 days ago, he said don't. So maybe let him take this one.
I knew I shouldn't have written that. Yeah. I said no, but I actually need to expand on that. Like, you can use it, right? You can proxy anything. I mean, I don't know, at least in Linkerd land, if it's a TCP connection, it will proxy it for you. We don't have protocol support specifically for Kafka, but that's something that could be added. I think Istio has it. I think the reason I wrote no is more because the value props are not quite as strong in that world, you know, especially the kind of reliability aspect of things is done in a different way in the queuing-based system, and you know, so a lot of the cool things that the service mesh can do around even some of the observability stuff, it's just not that interesting when you're working with queues. So it's not that it's zero value, it's just that it's a lower value for the same cost.
A lot of that has been built into the SDKs that you would use to talk to the queue, right? And that's why it's lower value. The other problem is just it's a black box, right? So we don't like it's a bus that things go into and things come out of. And today the service mesh implementations require causality.
Yeah, I mean, most of the all the things that the mesh would be helping you with would be, transport security if you weren't implementing that consistency with the library. Maybe the ability to cross some network boundary, right? Some basic kind of lower level network thing, unless you had actual protocol support for that thing. And then the question is, what would you be doing with protocol support for that thing? The primary reason we hear for people asking for support for that thing is so they can get telemetry out in ways that are non-standard baked into the library, right? So they want to kind of bridge a gap there. And that's a real use case, so that's why we're doing it. But the libraries do a lot of work at the protocol level, so you have to look at the gaps.
So what we find out, a lot of users are using Kafka type of messaging service as external services with Istio, and the main reason is because, for example, the Envoy sidecar using Istio doesn't have support for Kafka protocol. I believe it's on their roadmap, so we couldn't add more native support for messaging systems within Istio, but that's something, we find a lot of people interested in. They're just building external services as a stopgap solution.
All right, I got one right here, and I got you next. Here you go.
It's a bit abstract, so work with me on this one. When you're defining your APIs and designing them, can you tell me some of the considerations you go about for driving adoption, like the design of the API, and like what are some of the things you've done to bring more people to it?
That's a big open-ended question. First to try and then try again is probably the first one. I don't know many APIs that have been successful out the gate without at least going through one round of competition with the user. A couple of key things. Istio has gone through a lot of user feedback. We've taken a hard look at the APIs and continue to try and evolve them. One big mistake I think that we probably made early on in the API was not considering the kind of human unit of edit, where you'd have a resource for every individual HTTP route, right? And so then you asked a human being to go and understand, well, how is the system routing your traffic? And they had to go and look at 60 YAML files, right? So that's just not a good API, right? That's going to just destroy people's ability to understand the system. So unit of edit is really crucial. And we've actually done a lot of work to kind of take APIs that were disaggregated and aggregate them back again. And then you still have to have situations where you're composing resources, right? So then you have to be very careful about the semantics of composition, right? And how that cooperates with unit of edit. So, if you look at the earlier versions of Istio in 0.7 or 0.8, you'll see HTTP route, and now you see virtual service. And they do the same thing, they just do it very differently. And we're much more specific about how, when you compose virtual services into one gateway, what the semantics are. And that was a very big thing, because that was hugely impacting the usability of the system. And so it's something we think about a lot when we design or redesign APIs. The exact same thing happened with the authorization policy APIs in Istio, which are now much easier to understand and have a coarser grain than the earlier iterations did.
Yeah, unit of edit, unit of ownership are the two keys. But those don't make an API usable by themselves, they just make it composable and reasonable. because clearly taking that into consideration did not make the Istio APIs easy enough for everybody to pick up and use, right?
Yeah, I really like that question because I think, so one of the goals for Linkerd is we want to reduce as much as possible the operational overhead of running the system, because our adopters are our users. And there's all these like crazy touch points that happen. If you think of like the engineering team roughly being composed of platform owners who are like doing Kubernetes and service meshy things, and then service owners who are writing code and deploying it to the platform. There's all these weird touch points that the service mesh is kind of in the thick of between those two teams. Especially around like what is the behavior of this particular service? How should retry policy like be affected, or what's the rate limits for the service? That's information that that the service owner kind of understands and needs to encode into the platform. The platform owner doesn't understand the mechanics of an individual service, but maybe is providing the platform by which that information gets expressed. And so a lot of, kind of the design time and energy on the Linkerd side is into, how do we, I think Louis is exactly right. Which human being is going to be editing this, and what's their role, and what do they have to know about the rest of the system? And so in Linkerd, we have this thing called service profiles, where you define configuration on a per service basis. And then, like, you could express this in 70 different ways. We could have spread it out differently, but we attach it to a service because that was kind of the most natural way from the human perspective of how you're going to configure this stuff. The other thing that's been really interesting for us now that we are not just producing Linkerd, but running Dive, as that Dive runs on Linkerd. So now we're actually running Linkerd in production ourselves for the very first time, and so now we're like really feeling the pain. So we've gone from like having, what I thought were pretty good conversations with our users to like, oh man, we're using this thing and we're waking up at 3 a.m. if it's screwed up, and that's been eye-opening for us.
So I wanted to add it's kind of like like you have the ability to make a very opinionated API, which would be very easy to use there, versus to actually have an API that would be so generic that it would be very hard to the user to handle that, but it can use every use case that anybody wants. And I think this is always a trade-off that, people are talking about it. I mean, to me, I'm really good, with Solo or the SMI or everything that we're doing, we're kind of like trying to think about the user, but that means that we're opinionated, right? And this is what we're doing. We are opinionated, and it will be perfect suit to that solution that we're trying to solve, but it's not going to solve any problem in the world. So, treasure.
We have one more right here, and then I think we're going to have to close down. Christian? Oh, sorry.
I was just gonna say, from the console point of view, we're trying to like make easy, and then have kind of escape hatches where you can kind of do the really complicated power user things. And the other thing that we're dealing with our APIs is because we came from like a VM world, and now we're also supporting Kubernetes. How do you balance like kube native with also like how people can run things on their data centers, in their VMs? Like it's not necessarily matching up, right? And so that's a kind of something that we're working with there as well. Anyway, next question.
Kind of like almost a follow-up to that question. I was wondering if you had any thoughts on how to handle the conceptual overload that so many engineers have now. Like those of us on the infrastructure network teams mostly get how like Kubernetes and service mesh type works, but our poor application developers who are trying to understand these kind of like layered abstractions and like edge cases on actual implementation, it's a lot to fit in your brain. So any thoughts on how we could tackle that?
Totally, yeah. I think like from the way we look at things as this personas, right, and who's doing what. So from like the service owner, they know which upstream they want to talk to, right? But then who approves whether they can talk to that? So that might be like the security team or someone on there who has like, so that's why like in console you can annotate which upstream you want, but then intentions, which are you allowed to talk to that upstream or not, is a separate ACL token, and it's a separate kind of persona there. In terms of like routing config, that's kind of like, it depends on the team. So some teams don't want to think like, I know a lot of developers just don't want to ever think about like routing and stuff like that. They just want it all to work, and whoever can just DevOps team can handle it. But you're always going to have some people that are like, okay, well, I actually want to know why my app was retrying. And you're like, oh, it's because it was returning a 200. It was a get call, and we retry get calls, right? And they're like, oh, no, this is a specific thing. I don't want to retry that get call. So I do think you need to have kind of like that way that the developer who wants to get into that can actually configure those things as well. So I think it's hard. It's like there's going to be I forget the word, but basically like, there's like lots of different kind of ways that people want to do it, and so it's actually difficult. And I think you need to just provide ways to do it for every persona, but kind of make it more easy for the personas, like their main use case, make that easy.
Yeah, I would say this is something a service mesh really make it easy to separate from the mesh operator and your security operator to the developers. What's really interesting is that the mesh operator and security operator can be more in charge of the service mesh YAML file and be able to tweak it without having the service owner, the developer to rebuild the images. So sometimes, a lot of times, it doesn't even need to redeploy their services because you could tweak like the timeout, retries, circuit breaking, all that without even consulting the developers, only if there's a need. So the nice separation brought by service mesh really made it easy. And what we're seeing a tremendous trend is to develop different services, to divide them maybe by namespaces, and then you can have different configuration per namespaces to have each of the team separated nicely.
Yeah, so this is one of the most common problems that I run into when we talk with users, right? Is how do I give my app developers the control that they need over the parts of the mesh that they need to control, but hide the complexity, right? And so this is where, to the point that Louis opened up the discussion with around people building management planes, that's a large piece of it, right? So I think that this is really the role of the platform team in an organization. What you really should be doing is not giving your developers the mesh API. You should be giving them, though, some boxed version of that, some subset of it, which covers the use case that they should be addressing, right? Certainly, at least that's closer to the intended use case with Istio, right? I think Louis wrote up a blog post, for example, about the kind of our design philosophy with the Istio APIs, which is not centered on usability, but is centered on operationability, right? Operability, giving the power of Envoy in a way that can be used across a fleet, right? And that's a lot for an app developer to have to think about. And the answer is, like Lynn says, most of the time they don't have to think about it. So just don't even give them those APIs, right? And to this point, if you need that break glass, you have the full APIs behind the scenes that you can. Those teams that are sophisticated, that want more control, take it upon themselves to learn that, right? And that's a reasonable trade-off, right? So you provide an easy, happy path, and allow them to drop down if you have to. And that's what we've seen, at least in the people that I've been working with closely. That's the route that we've been seeing, and that's been pretty effective. The other key piece is just do features incrementally, right? So don't just throw the whole thing at your devs, piece by piece.
So I just say that to me, the application owner doesn't need to know that service mesh is even running in your infrastructure, right? I mean, they shouldn't know. It's a feature to them. They want a retry. They should tell me that they need a retry. They shouldn't even think about the API or about service mesh in general. They shouldn't know. They will not know, right? It doesn't make any sense to ask them to write all those YAML. So yeah, I mean, to me, this is something that we totally should hide from them.
All right, that was the last question. Can we all please give the panelists a round of applause? Thank you.